Next is question number 10.11. The question reads, how will you bring about the following conversions? So in this, the first one is the conversion from ethanol to but-1-ine. This is the question. Alright, so you are going to convert ethanol, which is CH3 CH2 OH to but-1-ine with a triple bond. So this is the conversion you are going to bring about. So for this, let's see what we have to do. So for this, if you see the reactant, you have 2 carbon in the reactant, but here you have 4 carbon, which means you need to double the chain, right? So for that, we are going to do certain reactions. So first is we are going to do CH3 CH2 OH. This alcohol, let us convert it to a chloride first. Only then you can do any other longer chain and things like that. So we'll convert it to a chloride, and for that we have various reagents that we want. So I'm just choosing out of that SOCl2 in the presence of pyridine. You have other reagents like PCl5, PCl3, Lucas reagent and so on. So you can choose any one out of it, whichever you can remember. Now once I have converted to a chloride, I need to add a compound which will double the chain, which means I need 2 more carbons. And that I will get from a Grignard's reagent. Alright, so I'll take an ethyne anion with magnesium and a bromine. So this is going to be my Grignard's reagent. This will replace the Cl to give me my product. Alright, so triple bond and a CH. So that is but-1-ine from an alcohol. Probably you can find various other methods, but we are only going to stick to the ones that are there in our syllabus. Alright, now next, second one is ethane to bromoethene. Ethane to bromoethene. Alright, so when I say ethane to bromoethene, it is CH3 CH3, which will give ethene with a bromine atom. So I'm going to maintain one double bond as well as a bromine atom in it. Alright, so here let's see this. So I have CH3 CH3. Now remember, I need to have double bond as well as a bromine. So for that, first thing is I'm going to brominate the compound. So when I add Br2 in the presence of sunlight, if I place them, I will get this as CH3 CH2 Br. Okay, I've got one bromo ethane. That's not enough. I need to have a double bond too. So what will I do? To this compound, I'm going to do an elimination, adding a base. So when I do that, I'll get a double bond in the center, eliminating the Br. Okay, now in the next one, I'm going to add bromine in CCl4. Now when I add bromine in CCl4, what will happen? I'll get a dibromo compound. So here I'll get with a Br and single bond with a Br. Further, when I try to do a reaction here, when I'm going to do with alcoholic potash, which is nothing but the elimination reaction, one Br and one hydrogen from the beta carbon. So for if I'm considering this carbon as an alpha carbon, this is going to be the beta carbon. Or if I consider this as alpha carbon, this is going to be the beta. So either one, I can get my product, which is CH2 double bond CHBr. Alright, so it's like an addition elimination reaction to get your desired product, because we need both double bond as well as Br in this case. Alright, that's why we had to do multiple addition and elimination of your compounds. Now, next one is third one. For the third one, I'm going to have propene to 1 nitropropane. So it's propene to 1 nitropropane here. Now for this, I'm going to have CH3, CH double bond CH2, which will give CH3, CH2, CH2, NO2. Alright, so this has to be the conversion. For that, converting directly from a double bond to a nitro group, we have not learned, we don't have reactions. So what we will do, first convert this to an halide compound, then from halogen it's easy to convert to nitro group. Alright, so here I have CH3, CH double bond CH2. Now to this I'm going to add a halogen compound, of course, HCl, HBr, whatever. But when you do that, you are going to take HBr preferably, because that's something that everyone will know. When I do this HBr addition to a double bond, it's going to follow Markovnikov's rule. And as per Markovnikov's rule, the Br will go to that carbon that contains least number of hydrogen atom. But that's not what we want. We want the other product. So for that, we are going to do the anti-Markovnikov rule. When I do that, I will get CH3, CH2, CH2, and then a Br. Now from a halogen to convert it here, we have learned those reactions which was in the presence of AgNO2 or KNO2 and so on. So one of those reagents you use here, and it will just convert to a nitropropane. Alright, so it's a two-step reaction. Now, next one is the fourth one. For the fourth one, I have toluene to benzyl alcohol. Okay. Now, toluene is this, a benzene ring with a CH3 is toluene, and this is going to get converted to benzyl alcohol, which means CH2OH. So that's going to be my compound. So for this, you need to do your reaction on the side chain of a benzene ring. Alright, so for that, I'm not going to do any electrophilic reaction that's going to attack on the benzene ring. Instead, I'm going to do chlorination using UV light. Okay, or I'm going to heat it. When I do that, I will have chlorination not in the benzene ring but on the side chain. Now from here it's easy. It's just a simple nucleophilic addition reaction. Aqueous NaOH, and then the Cl will be replaced with OH, which is the benzyl alcohol. Alright, so I will not do any other reaction because it's going to affect the benzene ring and you're going to have an electrophilic substitution reaction. So be very careful when you're dealing with reactions where you have to convert a particular group to another group where you have a benzene ring involved in it. Okay. Now, next is going to be the fifth one, which is propene to propine. Alright, now propene is CH3CH double bond CH2, which will get converted to propine, which is C triple bond CH. So the difference is only by a single bond, right? But the process is a two-step process here. Alright, so let's see how it is. So here I'm going to have double bond CH2. Now I'm going to do Br2 in CCl4. When I do that, Br will get bonded on both the carbons, breaking that double bond. Alright, that is two of it. Okay, now further, when I add alcoholic potash, which means I'm going to have a beta elimination here. Now when I do beta elimination, one Br and one CH hydrogen will go out. So I'll get this as my product. Alright, further I need to come to an alkyne. So what will happen? Again I'm going to repeat the same process and I will get my compound out. So I'm repeating Saytzeff rule 2 times. Last two reactions are beta elimination reactions. 2 times are repeated. Next one is ethanol to ethyl fluoride. Again very simple. We need to show ethanol, which is CH3 CH2OH to CH3 CH2F. This one preparation we have not learned directly, where you're taking an alcohol, converting it to a fluoride, but instead you can take an alcohol, convert it to a chloro group. Chloro group to fluorine group is going to be a Schwarz reaction. That's easier for us to do. Alright, so let's do that. So again here I'm going to take CH3 CH2OH. I'm going to treat it with any one of the chlorinating agents. I'm taking SOCl2 and pyridine. You can take any other. CH3 CH2Cl. Now from this to fluorine, it's only by an halogen exchange method. So I'm taking AgF. I'm going to follow Schwarz reaction. In the presence of dry ether, it will replace the Cl and substitute with fluorine atom. So very simple method again, if you know your reactions correctly in the chapter. Now next one is 7th one. It says bromomethane to propanol. Alright, so bromomethane is CH3Br to propanol is CH3C double bond O CH3, which is acetone. So now I need to know that I know that I'm going to have to add 2 more carbon atoms to the reactant to get my product. So whenever I'm trying to add a compound, to add a carbon atom to extend the chain, obviously one of the process has to be using the Grignard's reagent. That's one of the process. So let's see how to do it. So I have CH3Br. Now what I'll do is, I need to use a reagent that will give me an extra carbon. So in that case I'm going to use, in this case I'm going to use here now KCN, because I'm going to get a carbon from CN over here. So I'll get CH3CN. Now to this, what I'm going to do is I'm going to add a Grignard's reagent because I need 1 more carbon. So I'm going to take CH3MgBr. We have done this reaction where to a cyanide group I'm going to add a Grignard's reagent. I'll end up getting double bond nitrogen here. We've done this reaction also in the syllabus, and this will come here. That's the CH3 from the Grignard's reagent. This one simply on acid hydrolysis will give me acetone. The double bond nitrogen will be replaced with the oxygen coming from water. Alright, and that is going to give me propanol, or I can simply call it acetone. Now next one is the 8th one. This is but1ene to but2ene. So this is CH3 CH2 CH double bond CH2 to CH3 CH double bond CH CH3. So it's only in a shift of a double bond that I need to bring about the reaction. Again a very simple one. So let's see how to do it. I have CH3, CH2, CH double bond CH3. So first of all, I want to remove the double bond by adding HBr following Markovnikov's rule. So I'll put CH2, CH, Br and the CH3. Alright, now once I do this, alright, now I need to bring about my product. So what will I do? I am going to do a Zaitsev rule, which is in the presence of alcoholic KOH. When I do that, as per the rule, hydrogen is removed from that carbon that contains least number of hydrogen atom from the beta carbon. So this carbon, the hydrogen goes off and I'll get my product over here. Alright, so the first step is going to be Markovnikov's rule. The second step is Zaitsev rule. It's a very simple one. Okay, now next one is 9th one. It says 1-chlorobutane to N-octane. Alright, so here let's draw the structure. I need to show 1-chlorobutane is CH3, CH2, CH2, CH2 and the Cl, and I'm going to form N-octane. N-octane is what I just have a long chain of 8 carbons. Octane is 8 carbons. So I have, that's my octane chain. I have 1, 2, 3, 4, 5, 6, 7, 8. This is my N-octane. It's a clear thing that I have 4 carbons in the reactant. Double the number is going to be my product. So I'm just going to take 2 of this in the presence of sodium and dry ether. This is a very simple Woods reaction. Alright, this is a Woods reaction. Very simple one. It's just doubling my alkene chain. Alright, now to the last one, and the last one is benzene to diphenyl. Diphenyl as in 2 benzene rings bonded together. So for this, to form diphenyl, I know I have Woods reaction, but for the Woods reaction I need a reactant which is chlorobenzene. So I can simply do a simple chlorination that you learnt in first year chemistry. Anhydrous AlCl3 in presence of Cl2 will give me chlorobenzene. Alright. Now this itself, if I take 2 of this in the presence of sodium in dry ether, this is going to give me what is called as a biphenyl or a diphenyl. Alright, so this is the diphenyl. I prefer to write the diphenyl like this in order to show the proper structure. The bonds are opposite over here due to rotation across this bond over here. That's why I've written the bonds the other way. But that's a bigger topic that we will be learning it in a much higher grade. Let's not focus on that right now. So first one is going to be electrophilic substitution reaction plus chlorination. The second reaction here is going to be Woods reaction. They're all very simple reactions right out of your preparation methods and chemical reactions. You will be comfortable in solving this like this, like trying to get an idea of what reagents to use, reagents to use, only once you are thorough with your reagents, what functions they do, and you're thorough with, okay, if I have chlorination, this are the reagents, or if I have halogen exchange, then these are the possible reactions that I can have. So you'll come across all that only when you're really thorough with your chapter. So I would suggest keep practicing such questions. Pull out the questions from the past year's paper. This will actually help you memorizing your reagents much better than learning it individually. Alright.